Yes, good day, everybody. Welcome once again to this learning channel where learning is fun. Today, I want to bring to us the secant method. Secant method. Now, the secant method is a mathematical method used in finding the root of a function, and I must quickly say it is a variant of the Newton-Raphson's method. That means it was derived from Newton-Raphson's method. Remember, Newton-Raphson's method, short NRM, is given by the formula xn plus 1 to be equal to xn minus f of xn divided by f prime of xn. So this is Newton-Raphson's method. The video for Newton-Raphson's method is in one of our previous video. So if you want to watch that, don't hesitate to check through our channel for Newton-Raphson's method. So we have the Newton-Raphson's method. I'll basically quickly explain that if you want to find the next n, what you simply use is to do this simple iterative formula here, meaning that you have your xn, that is the previous n, subtracting the function of xn divided by the f prime, that is the derivative of that function in the numerator, and then you keep doing that over and over again until you get an estimate value of x that is not changing, and then we say we have a point of convergence, and we conclude that that is the root of the function. And then for secant method, we can actually derive secant method from this formula, and basically we look at this part of the Newton-Raphson's method and we do a tweak around that. So to say, we have f prime of x n, let me say that, will be equal to the changing function, which is f of xn minus f of xn minus 1, that is little difference in x, with respect to changing x, xn minus xn minus 1. That is changing function with respect to changing x. And then that is what this part of the formula means. And from here, if we bring these into this formula, into the Newton-Raphson method, we can have substituting into Newton-Raphson's formula. We're going to have this. We're going to have f prime. We're going to have xn plus 1 to be equals to xn minus f of xn divided by the entirety of this. Remember, we have replaced this to say this to be equals to this, but there should be bracket, and then we say this is going to be equals to f of xn minus f of xn minus 1 divided by xn minus xn minus 1, and then that's what we're going to have for the new Newton-Raphson's formula. And you look at this side of the formula, this side of the equation, we can rewrite this to say this is equals to xn minus f of xn multiplied by, we take the inverse of this, that is going to give us xn minus xn minus 1 divided by f of xn minus f of xn minus 1. So having got this, when you do the multiplication, this multiplied by this will give us, we have xn, that is this xn minus f of xn dot the entirety of this xn minus xn minus 1 divided by this f of xn minus f of xn minus 1. And this is what we call the secant method, as derived from Newton-Raphson's method. All right, in the part 2 of this video, we're going to actually look at the an example of the secant method. Thank you very much. Join me in the part 2 for an example. All right, so I have an example of secant method here, and if you have not seen the part 1 of this video, I think you need to quickly go back and check how we got this formula here from the Newton-Raphson's method. It is showing right there on your screen. Make sure you click on that video and watch. All right, now we have a question as an example, which says, find the root of the function x cubed plus x minus 1 after 5 iterations of the secant method, taking x naught to be equals to 0 and x1 to be equals to 1. Now I have this little table here for xn and the corresponding approximate value of xn after every iteration, which I'm going to fill up in order to help me monitor the values of my x. And then using this iterative formula, I'm going to derive the values of x2. I've been given x0 and x1, so I'm going to derive the value of x2, x3, x4, and x5 as approximate as the solution to the question. Now, I quickly begin and I rush over it. So the formula, I have x0 and x1 already, so I'm looking for x2. So I'm going to say x2, which is xn, which is 1 plus 1, which is giving me 2, 1 plus 1. So it's going to give me x1, the previous x, which is x1, minus f of x1 multiplied by x1 minus x1 minus 1 is going to give me x0 divided by f of x1 minus f of x naught. So the first thing I need to find is the value of f of x1 and f of x naught. So I'll quickly do that. So f of x naught is going to be equals to, for x cubed, is going to be 0 cube minus, plus 0 minus 1, and that basically gives me minus 1. And f of x1, f of 1 is going to give me 1 cube plus 1 minus 1, which is going to give me a 1. So 1, how did I get my 1? 1 times 1 times 1 will give me 1, plus 1 will give me 2, 2 minus 1 will give me 1. So that is f of, so x2 will now give me equals to, my x1 is 1, minus f of x1 is also 1 into the bracket of x1, that is 1, minus 0 divided by f of x1 is 1 and f of x naught is minus 1. So minus 1, remember x naught is minus 1, so I have minus 1, and that gives me, if I do this, I'm going to get x2 to be equals to 1 minus 1 minus 1, 1 minus 0 will give me 1, and I have 1 into minus 1 minus 1 will give me plus 1, and this is going to give me x2 to be equals to 1 minus 1 multiplied by 1 will give me 1 over 1 plus 1 will give me 2. So I have, just manage this little space here, so x2 is going to give me 1 minus 0.5, and 1 minus 0.5 is going to give me x2 to be equals to 0.5, and that is my first third approximate. That is x2 is going to give me 0.5, and I fill that into this table to say x2 is 0.5. I called this the first iteration. Remember, we were asked to after 5 iterations. So after the first iteration, we got the approximate value of x to be 0.5. Second iteration, this is where I'm going to derive the value of x3. Remember, n is now 2 plus 1 is now 3, so I'm going to have x3 is going to be derived using x2 minus f of x2 into the bracket of multiplied by x2 minus x1 divided by f of x2 minus f of x1. And I quickly like to derive the value of f of x2. So the value of f of x2 is going to be equals to 0.5 cubed plus 0.5 minus 1. All right, so I haven't gotten this. The cube of 0.5 to the power of 3 is going to give me 0.125 plus 0.5 minus 1, and that's going to give me 0.625 minus 1, and I'm going to get minus 0.375 as my function, my f of x2. So I'm going to use this in the formula and say x2, my x2 now is 0.5 minus f of x2 is minus 0.375. Don't forget the minus, and it's separated from the original negative sign. Multiply by x2 minus x1 is 0.5 minus 1, and divided all of this by f of x2 0.375. Sorry, it's a minus, and then minus f of x1. Remember, f of x1 have been evaluated to be 1. So evaluating this, I have 0.5 minus 0.375, and this will give me minus 0.5, and here I have minus 1.375. Okay, so multiplying the numerator, I have 0.5 minus, when I multiply this, remember the two negative signs will give me a positive, and that will give me 1875 divided by minus 1.375. So doing this arithmetic, that will give me x3 to be equals to 0.5 minus the division of this will give me the minus 0.1364. And then because of these two negative signs, I'm going to have 0.5 plus 0.1364, and that will give me my x3, final x3, to be equals to 0.6364, and that is my value, estimated value for x3. So remember our little value table, we have the value of x2 to be 0.5 and the value of x3 to be 0.6364. So I'm going to have you pause the video for a while to see if you can figure out the value of x4 and x5. Then we come back to see the value. All right, if you have paused the video and you have been able to figure it out, I hope you get it right. So our next value is going to be x4, which is going to be equals to x3 minus f of x3 into x3 minus x2 divided by f of x3 minus f of x2. Remember, f of x2 is equal to 0 minus 0.375. Now we have to evaluate f of x3 to be equals to the value of x3 that we got is 0.6364 to the power of 3 plus 0.6364 minus 1, and this will basically give us minus 0.1059. all right, and then we use this in the formula to say x4 is now equals to x3, which is 0.6364 minus f of x3 now is going to be minus 0.1059 multiplied by x3 0.6364 minus x2. Our x2 was let me quickly check. X2, I think I have to check from the value table. My x2 is 0.5. 0.5, as we can see from here, x2 is 0.5. okay, so everything divided by f of x3 is minus 0.1059 minus f of x2 is minus 0.375. Of course, these two negative signs will we will have a positive sign there. So basically x4, after evaluating this, will give us x4. Our final answer for x4 is 0.6903. So we quickly put that in our value table, 6903. Now basically, if you look at these two, x3 and x4, we have 0.6, 0.6, but approximately they are not the same. So we cannot actually say at this point we have achieved the goal. So we need to go for the fourth iteration. By the way, this is the third, and now the fourth iteration, where we will be having the value f of x4 now will be equals to f of x will be 0.6903 cubed plus 0.6903 minus 1, and that will give us 0.0192. okay, having gotten that, we know what our value of x3 is, f of x3. So our x5 will be equal to x4 minus f of x4 dot x4 minus x3 divided by f of x4 minus f of x3. And slotting the values in, we have x4 is 0.6903 minus f of x4 0.0192 multiplied by x4 minus x3, that is 0.6903 minus our x3 is from here 0.6364, 0.6364 all divided by f of x3, f of x4 0.0192 minus f of x3. F of x3 can be deduced from here, minus 0.1059, and of course x5, after doing all of this, x5 will be equal to 0.6 8, 2, 3. That's our x5. Let's quickly start down into our value table. 0.6823. Okay, so that is example of secant method. Now there is one more iteration I want us to perform. That is our fifth iteration, x6. The value of that sixth iteration, x6, is actually 0.6823. So all I need you to do is to figure it out, work it out yourself, our f6 using this formula, and then see if you get 6.83. And if you observe, x5 and x6 are actually the same. The value is no longer changing, and so we say we have the value have converged. So that is secant method. Thank you very much for watching. If you are new on this channel, please hit the red subscribe button. Drop a comment if you have enjoyed the video, share it with others, and then let them know about it. And more importantly, please stay with us on this channel as we turn out, or we throw out, even more learning videos. Thank you very much. God bless you.